Hello, this is Professor Billiar at Worcester Polytechnic Institute, and I'm going to do a demo, about 10 minutes, about how to run a test using Bluehill3 software using an Instron 5544. Now, we've already logged into Instron and put our names in our log book so I know who's using the computer. Put on our personal protective gear, no gloves on the computer. Put the grips in and tighten them. The Instron's already turned on. Bluehill3 I've already logged into. So now what I want to talk about first in part one is software programming, the specimen type, measurements, and test control. And I'll get into calculations and graphs in the second part, another 10-minute video. So I want to do a uniaxial test. I have a piece of leather in the grips already. I've already balanced the load cell before I put them in the grips and zeroed the extension, but I'm going to have to put a tear load on before I do the test. But now I want to do a uniaxial tensile test. So I can either choose method or test. I'm going to choose test. I'm going to select, I can choose here a test that's already been used recently, or I can browse, and I'll do a browse. And on our computer, it's under a very long trail of these different folders, but under Instron examples in Bluehill, once you get there, there are some standard Instron examples, and I'll pick just a tension example here. Opens a file, and I'm going to use a leather here. And once I choose that, then I come where I can also look at the administration reports and methods. So I could also have gone into just methods to define this test. So under methods, I have a bunch of different prompts on the left here, and I'm going to start from the top and go down and only hit the ones that are important to run a test. And then again, for the calculations, I'll do another video that you can watch. So first thing is, what kind of test is it? A tension test, and I can use different types of units. I'll use metric units this time. I can select the sample. There's a bunch of notes, not really that important for now. I can put number inputs and text. But for the specimen, I need to pick what shape it is, rectangular, circular. Mine happens to be rectangular, none of these other types, so I'll choose that. I could also put a specimen label, which will come up every time. I'm not going to do that now. I can also put notes and different types of inputs here for the specimen. You can play with that. For measurements, the standard measurements are going to be time, extension, and load. That's what the machine can actually measure. There's virtual measurements such as tensile strain. As you notice here, it's a virtual measurement. It's a calculated measurement by taking the extension and dividing by the initial length, which is defined by the user. You could also do others. As I mentioned, I'm not going to really talk about calculations, but these are calculations where the calculations are made. Are they made at the maximum load, at break, etc.? And I'm just going to use the standard ones that are already programmed in here. And I go down to test control. Here's the important part for this video, is you have to set what is the type of test you're going to do and when is it going to stop. So for this test, it will start with the start button. That's the only option we have with this, because we don't have any other lines hooked up. We're going to measure strain using extension. We don't have any extensometers that are connected, so we can't use anything else for now. Those are more advanced types of tests. In a whole separate video, I'll talk about all types of pre-tests you can do, both static preloads and dynamic pre-cycling. So now getting to the crux, what is the test? Generally, you're going to do a ramp test. You can do ramp with extension control, or you could do a load control, or stress control, strain control. Extension control is going to be the most stable kind of control because it doesn't depend upon your sample. If you have a stiff sample or a soft sample, you'll get different types of control when you use load control. And it's a screw-driven machine, so it is more stable under extension control. Pneumatic machines can work better under load control. Depending on the sample size, you'll pick a rate. 10 millimeters per minute is pretty good for pretty stiff material. This leather is pretty soft, so I'll give it 20 millimeters per minute. You have to hit enter to have it recorded. You could do separate ramps after the first ramp and have a changeover. I'm not going to get into that detail, but you can play with that on your own. Then once you're running a test, the end of the test is critical. Generally, the criteria, if you're going to do a failure test, so ramping up till it fails, a rate of load criteria is the most useful, and the standard in this software is 40%. So that's a 40% change in the rate of loading. So if the sample fails and the force drops quickly, it'll stop the test for you. But maybe you're doing a compressive test where you don't want to get anywhere near the grips, or maybe you want to stop that as a displacement for some reason. So if, let's say, the extension goes beyond 50 millimeters, I might want to stop. Another one could be load control. So I could say if the load gets above, this is a 2,000 Newton load cell, so I have it under kilogram force. I'm going to go back here and use SI because I'm used to working in newtons. Then when I go under test control and my end of test, it'll have it in terms of newtons. So I want to stop at, let's say, 1900 newtons because I have a 2,000 Newton load cell and I just want to be safe. Now, we already have under load cell here limits of plus or minus 2,000 set in here electronically, but I could be a little more conservative if I wanted to. And then when whatever of these criteria are triggered during the test, I have it set so it'll stop and then prompt me and then return. You could also just have it stop and do a manual return, or you could have it automatically return, but I like to have it stop and then prompt me to return the specimen because I can check out, make sure there's nothing in the way, and have it return. There's also other options such as specimen protect, which you can read about. Now you have to take data during your test, and in this case it's set at 50 milliseconds to take data. That's going to be a lot of data, so I'm going to go down to 100 milliseconds here. But in case there's a very fast change in force, I can also add another. And so I can take data every, let's say, there's a 2,000 Newton load cell, so 2 newtons would be 0.1% of that load cell. That's plenty. That's actually below the accuracy or linearity of the load cell anyway. So I could take data every 2 newtons here, in addition to every 100 milliseconds. Now I could have it display different things on the top. Here it's displaying extension and load. I could also have it do tensile strain and tensile stress, and even some calculated parameters such as slope along the way I can calculate during the test. I can also set soft keys, and soft keys can do things such as a balance, and that would balance the load and zero the load. And when I click on that, it'll do it for me. And I could also do a zero extension, and those are up here on the top, so I don't have to look for them anywhere else. Of course, I can also do it by using these icons up here, but these are just fast soft keys. On the frame itself, I can also select different parameters of the frame, and on the soft keys on the frame. This will be the first soft key on the frame. This will be the second soft key on the frame on the little controller. I can also define things with the grips, which I'm not going to do right now. I'm not going to work with the workspace much here because it's not needed to run this test, and I'll get into that in the next video. But because every specimen could be different, I'm going to have the user input specimen label, the rate they want the test to go at. I already selected 20 millimeters per second, or millimeters per minute, but that could be changed by the user. I could also have number of units, choice of different units, and usually I will have the length so it can calculate strain for me, the thickness, and the width of each sample before I test it. Again, the results tables and the other displays I will talk about in the next video. Also, where to export the data I will talk about in the next video. Now the test is going to be prompted, and it's going to tell me when I need to enter information. I'd like to do that before each test, And then also I want it to stop and show me the workspace and the graphs after the test. And I can have it prompting me many more times. Okay, so then we go on to actually doing the test. I'm going to save this template, and I'm going to put it under anywhere I want. I can put it under, this is my name, so I'll put it under my protocols, and I'll call it leather tensile test. And now I can go ahead and run a test, and this is my sample 1. I already said it's going to be at 20. I can measure the width, thickness, and length of my sample. I'll do that after I put a small tear load. Again, I've already balanced the load. I'm going to put a small tear load on. So after I have a little tear load on, I want to zero the extension. I can do that here or here. And you'll notice the extension says 0, the strain says 0. I don't want to zero the load. I'll measure the dimensions. To save time right now, I'll just jump ahead and enter what approximately they are. And then I will run the test after I put my safety stop. We have safety sheet to put in place. I'll make sure my sample is tightly gripped. And I'll start the test. And you can graph different things, which we will do in the next video. If you notice, the load is being read out here, and also the extension and the tensile strain and stress are being calculated automatically. And if it broke catastrophically, it would have stopped it sooner, but this broke slowly, but it eventually went to a 40% decrease. Now I can, it says remove specimen, then click OK to return to 0. I'm just going to return it to 0 because I know I've already broken the piece of leather and the grips will not hit each other. And that's the end of the video about the basic testing, uniaxial testing.